So this is the question on Leetcode number 1143, which is a longest common subsequence. That is our DP on string question there. So now coming to the question part. So what's given in the question? So here we have simply given the two strings there. That is text1 there and text2 there. And you have to return the length of their longest common subsequence possible in this. And if there is nothing common subsequence present there, we have to simply return the 0 there. So like what's the subsequence, we know very well. First of all, like subsequence is separated, or it is different from the subarray. Like it doesn't need to be continuous there, but it should follow the order there. Like let's say you can say there, if you have to given a very main string there, so any of the subsequence can, so this can be said as a subsequence. Like if you have to say a, c and e. Okay, so this is the definition of subsequence. So now if you have to say for this test case a, b, c, d, e, and there's a c, e. So if we have to find what is the longest common subsequence present between these two texts there, so we can see very well like a, c, e, and here also a, c, e. So this is the possible longest common subsequence, that is ACE, and since we have to return the length, so that's why its length is 3. If we have to coming to the example number 2, so here we also see like ABC and ABC, since these two strings are same, so the common subsequence is also same, which is equivalent to text1, or we can say text2 there. Now coming to the third test case, ABC and DEF. Here we are not able to find any of the common subsequence between these, so in that case we have to simply return the 0. So means that's the question here. So like what's the intuition behind this question? We are given the two strings there, and we need to find what's the longest common subsequence to the both. Okay, so now like I have to come to this notepad there. We can say one thing, like whenever if our characters match, so we have to include it or move our both pointers, like what we do here. Let's say I have my string given there, like if I have to call about this, wait a second. Okay, let's say my string is, let's say this is a AB there, that is our S1 there, and another string that is S2, which is of A and C there. Okay, let's call it ABC there. So these are the two strings given to us, and now we have to check what's the longest common subsequence between these. So first of all, to associate with to whom this string we are talking about, so for this we have to simply mapping this with using the two index there, like this is index number I there, and this is index number j there, to denote to which is string we are talking about. Okay, so like we simply traversing this I and j simultaneously or one by one, such that we are simply storing what are the correct in which case characters match and which they are not matching. Okay, so we can say one thing there. First of all, if our characters are simply matching there, so in that case we have to include it, and simply we can say move both pointers there. Okay, so this is the basic idea behind this. So this is the case 1. And what if the other, if these are not matching there, so in that case we simply have to, we can say we have the two choices there. Okay, the choice number 1 is simply skip from S1 there, and the second choice is simply skip from the S2 string there. Okay, so now if you are clear about it, so we have the two choices, either we have to skip that part, or either we have to let's say I have to see, I have to explain it very well here. I have to draw here. So this is S1, it is nothing but the A, then B, then C there, and for the S2 I can say it is nothing but the A and C there. Okay, and now let's say there is a one, I can say this is for the, okay, so this is here I, and this is a j there. So we simply moves these pointers according to whatever the situation comes to this. Like we see two scenes there, if the characters matches or if the characters not matches there. Okay, so accordingly we have the choices in it. So we can say one thing, like at every step we either match characters or we have to skip one. Okay, so what we need to see in this question, we simply need to maximize this length there. So it means at every step we have the multiple choices. So in any of the questions in which we have the multiple choices or we have to try the different possibilities, so we simply, this naturally leads to use of the recursion. Okay, so it means we have to use the recursion here. Now coming to the since I have to say the recursion, so I can also define what is the definition of my state there. Wait here. Okay, so this is nothing, first of all this is f of I comma j. So like what it means, so it means nothing but the this is the LCS, means longest common subsequence. I can say this is the LCS length using strings from, I can say 0 to I there, and I can say 0 to j there. So this is the definition of our, okay, so this is the definition of f of I o j. This is LCS length using strings from 0 to I and the 0 to j. Okay, so like what we need here, so we simply need to return what was the we have to start if from our ending. Okay, so this we need to return in the question there. So like if you have to say about this question, if we say about a b c d e and a c e, means what we need to call here, we simply required to find the f of 4 comma 2. So that is nothing but the LCS length of this string from the 0 to 4th index, and this is the string from the 0 to 2th index. Okay, so this is the question there. Now we can see like we also do the what the recurrence relation here. So we can say one thing there, if our characters match, if matching theirs, so in that case we can simply, what we do here, we simply f of I, if we have to start for the f of I, so we can say we simply moves our both pointer and simply add a 1 here also. Okay, and like if not case, means in the case when it not matches, so in that scene we simply take the what are the maximum possible of f, either we have to move our I pointer here, or we can say either we have to move our j pointer here. So in both cases, whatever the minimum, whatever the maximum is our answer there. Okay, so that's the two things there. Okay, so now let's say we have to call for this dry running for this recursion tree. For the this case means s of 1 is abc and the s of 2 is ac there. Okay, so these are the two strings given, and now what we need to find, we have to simply f of 2 comma 1 we have to find there. Okay, so now come here, there's a c and c. So if now check whether there's a matching or there's not matching. Okay, so if there's matching, so what we need, simply 1 plus, now call for the move both pointer, mean they come for the I minus and j minus 1, means f of 1 comma 0. Okay, so means it returns 1 plus, now it calls for 1 comma 0. Now since here the characters are not matching, means here at b there's a I and j there's a a, so there's not matching. So now there's a two option, either move our I pointer there or either move our j pointer there. So if we have to call for the I pointer, mean is becomes 0 comma 0. Now call similarly here it become f of 1 comma minus 1. Okay, now we can say one thing, like whenever we have our strings given in the s1 here, s2 given here, and simply similarly our I pointers moves there and j pointers moves there, in that if there's a case arise in which our pointer reaches to starting it like goes beyond the starting, like what I'm saying here, let's say if I one thing as given here, let's say I'm talking about the s1, it is nothing but the something, let's say we can say a and b, then c, then d, then y, what is the, and similarly our s2 is nothing but the a, then h, then k, it is n. Okay, So now let's say if I'm talking about this, let's say I'm standing at this positions. Here is my eye there. Okay, now it goes for this eye, now it goes for this eye, now it goes for this eye. Similarly, this our eye pointer initiate from here, and similarly j initiate from here. If in that case arise means our eye pointer goes beyond the 0, so in that case it is not possible to find any of the common subsequence so in that case we simply return 0. So what I have to say, in that case if our I is less than equal to 0, I less than 0, or I can say our j less than 0, so in that case it is not possible to find, so we simply return 0. Okay, so this is our base case for this recursion tree. So that's why we have to see here, if any of our pointers goes beyond 0, so simply return 0. So here you simply return 0, now it returns 0 here, now it becomes 0, so it simply returns the 0 value here. Okay, so it simply returns 0, and this 1 plus this 0, so it means it returns simply 1 there. Okay, so it return 1 there. Now coming to the right subtree part, f of 1 comma minus 1, again it returns 0 there, so it returns 0 there. Now for this f of 1 comma 0, from left it gains 1, from the right it gains 0. So what are the maximum it has to return, means we have to return maximum, so it means it has to return the 1 there. Okay, now 1 from this left and right subtree, and since 1 from the during the returning means it simply calls returning 2 there, because 1 plus f of I minus 1 j minus 1. So from our f of 1 comma 0 it returns 1, and here 1 is already present there, so that means it returns 2. So what we see, there's a maximum longest common subsequence length is possible is AC, means that is a 2. So that's our dry run for this case. Okay, so now coming to the coding part here, like this is our brute force there. Here are the two, this is the main functions. First I define the size, it's as n there, and this is for the m. This is nothing but the s1 string and s2 string that's given in the question here. Now we have to simply return the sol function and simply return, this is our I pointer starting, and this is where our j point is starting here. Now this is the definition of our sol function there, this for the I, this for the j. This is for our base case. Whenever if any of the substring goes beyond the 0, it simply returns the 0, means it is not possible to find any of the common subsequence between them, because one string is like exhausting. So that's why this is for the base case. Now this is for if our characters matching here, so in that case we simply return 1 plus sol function, and there's a both pointers are moving. And if not matching, we come come down here, so there's the both things there, like it means the I pointer is moving there, j pointer remaining. In the second case, I pointer remaining, j pointer moving, and whatever the maximum simply return that case. So this is the very basic code for this longest common subsequence. Now this is the brute force. Since every step we can say I'm talking about the time complexity, so since the size of the text one, or we can say the s1 string is n there, and this is the size adds m there. So we can say one thing there, like every pointer has the two options there. Wait a second here. So whenever we are talking about the substring 1, so substring 1 has there's n characters there, and each one has two possibilities, either take it or either include it or either exclude it. Similarly for this case, so there's a 2 power n for this, 2 power m for this, so means totally it becomes 2 power n plus m, because in power the powers are adding there. So this for the time complexity means simply exponential power. So since it is not acceptable, so we should go for seeing for the optimized version. And now talking about the of n plus n, this is nothing because of the recursion space, because we don't as such we don't use any of the extra space there, but in the worst case it has to pass all of the states there, so that's why all of the states becomes n plus m. So that's why it's space complexity. So since it is not acceptable, so we have to go for the another case is there. Now if we have to trying for the any of the test case in which a very big test case, so during recursion we have to see there are the many of the states that are repeating. So to avoid that recomputation, we simply storing that. So for storing we simply use the dp vector. So that's why it means we can now optimize this using our DP. So the method I am using here, it's simply memoization version. So this is the again the same code here, this is the same code here. The extra thing is simply use the DP vector. Now we can use the whatever the things are very here, we simply moves the our I vector and the j vector. These are nothing but the index vector. So that's why our DP is initialized with m there and the m here, and initialized with a -1. Now simply it calls forward and simply have to pass the DP in this main function. All of the code remaining the same way. It has to write because to check whether we can store its value in our previous cases or our previous pass there. And simply store the DP value here, simply store DP here. So again the code is remain the same there. Now time complexity is become the upper n of n into m because of the traversing of this DP here. Space complexity is because of we are using the DP, so that's our extra space there, and this of n plus m again for the recursion stack. So that's our question number LCS there.